Welcome to the Community Broadband Bits podcast from the Institute for Local Self-Reliance. This is Lisa Gonzalez. In this episode, Christopher talks with Sascha Meinrath from the Open Technology Institute at the New America Foundation. Sascha and Chris talk about OTI's Commotion initiative. Commotion is a plan to unlock telecommunications networks and change the basic structure from spoke to spiderweb. The result would be better connections, safer connections, and more affordable connections. Now to Christopher and Sascha.
Today on the Community Broadband Bits podcast, I'm sitting next to Sascha Meinrath with OTI at the New America Foundation, formerly the Open Technology Initiative, now the Open Technology Institute. Tell us a little bit about it and your background.
Sure. So I come out of the community wireless networking space. I come out of the indie media, radical media activist space. And the Open Technology Institute is, in many ways, a tech tank. It's located inside New America, which is a think tank, a policy institute in Washington, D.C., but our focus is very much on everything from technological development, i.e. programming and developing of new technologies themselves, as well as field deployment and implementation. So there's a field team. And then we have a policy arm, sort of the more traditional think tanky, wonky side of our work. And there's about 50 of us now all working on this intersection between technology and policy, educating key decision makers around these issues, working with communities to implement new technologies, document their impacts, and bring that knowledge to DC policy debates.
Okay, so what specifically are you working on? I want to talk a little bit more about Commotion in depth, which we'll get to, but I wonder if you'd talk a little bit about some of the other things that you've been working on.
Sure. So we work on everything from actually deploying networks in communities. We advise a number of funders and municipalities on issues related to community broadband. We do a lot of work on surveillance and privacy and documenting what happens there. We have in fact now the world's largest broadband measurement platform, Measurement Lab, and that's collecting about 500 gigs of data a day, has a couple 100,000 users a day. We have a number of projects in terms of responding to FCC dockets. In essence, we're one of the public interest folks that are working to open up our airwaves, as well as protect an open internet. And in terms of research and development, programming-wise, we have a project called the Commotion Wireless. And that is an endeavor to build a decentralized, peer-to-peer, community-owned, safe communications network that spreads connectivity to everyone on the planet.
So I think the audience knows community-owned. Let's unpack that a little bit by little bit. And I think this is something that others have said, and I first heard it from you. But explain to me, if I make a phone call to you right now, how that works and how it's different from how Commotion works.
Sure. So today, if you pick up your cell phone and you make a phone call, it's being routed through a central cell tower. And if I'm on the receiving end of that phone call, I also am routed through that central cell tower. And you're paying on the way up to that tower, and I'm paying on the way down from that tower. And if we are sitting, say, as we are right now, 2 feet from each other, we're still paying the same amount to those providers.
And in fact, it's specifically going through the tower only so that we pay for it.
That's right. And in fact, as we are here in the basement of a conference center, I don't even have connectivity on my phone, which means I can't make a phone call to you even though we're sitting 2 feet apart. Now that's absurd. It's architected in ways that are both more expensive and provide worse service for me. So the logical thing to do is to unlock features, to unlock functionality on our cell phones that would allow them to communicate in a peer-to-peer manner, i.e. would be allowing them to communicate directly with one another. And what Commotion does is it does exactly that. It provides a feature set so that cell phones can communicate with laptops and Wi-Fi routers and with one another in a decentralized manner, in a peer-to-peer manner. So if the traditional cellular infrastructures like a hub and spoke, think of it as a bicycle wheel, where everything connects through that central hub. What we're talking about is more of a spider web, where there's multiple different pathways between any 2 points on that web of connectivity. And that enables both incredibly low-cost communications, or free communications. It also enables for decentralized communications. This makes it both much easier to avoid extraneous billing. It also makes it much easier to harden your communications to make it more difficult to surveil or censor or monitor or control.
Now, you also said safe, and I'm curious why safe comes into it.
What we're building is a general use technology. It's a communications networking technology, and it has a lot of different use cases. It fills a lot of different needs. So one of them might be, for example, after Hurricane Katrina, we set up a communications network using earlier generations of these technologies to provide emergency communications in places that had no infrastructure left.
Mm-hmm.
Another use case might be if you're in rural America and you have no cellular phone system or no broadband connectivity. This enables you to, for very low cost, provide that kind of function for your community. And a third, and this is what's captured the imagination of some of our funders, like the United States State Department, a third option is to provide communications in places where cellular phone networks, internet communications are actively surveilled and monitored and controlled.
Mm-hmm.
So it doesn't take a lot of leap to understand that there's a lot of places on the planet whereby simply sending a text message can get you into serious trouble, rounded up, or killed. And so these technologies, by encrypting in an end-to-end manner the communications that runs over these networks, enable for safer communications. It enables people working in the world's hotspots, whether they're democracy protesters or human rights workers, to communicate without as much fear of surveillance and monitoring.
When you say a general use technology, I think the FBI, police departments get very afraid at the idea. We're already seeing this. There was just recently some hubbub about Apple's instant messaging being uncrackable, according to some law enforcement departments.
Yes.
So what would you say to a critic that says you're just going to make it easier for gangs to engage in extra-legal activities?
That critic is right. These technologies will make it easier to have secure communications. If you live in a civil society, if you live in a democracy, if you live in the kind of society that holds communications rights, human rights, our right to freedom of expression as fundamental, then that's the price we pay. The most dangerous technology that we have on the planet is literacy. Some of the most dangerous tools we have on the planet are pens and pencils and computers. And some people use these technologies for ill. But the overwhelming benefit to society, the incredible positive externalities of having access to education, of being able to use pens and pencils and computers, is so great that we understand how ludicrous it would be to say, you know what, we've got to eliminate this stuff because they might be used for ill. And as a technologist, I look at those that claim securing communications will only empower the bad guys as at odds with the last 1,500 years of communications forward movement. From schooling to the printing press to the radio and television and the internet itself. It is absurd that people that claim that technologies that can be used for such good should be made illegal.
So one of the ways I've started to think about this was to think everyone understands how email works in the sense that I have your address, I type it into my computer, something happens, it shows up on your computer. I don't pay for it, you don't pay for it. Is it correct to think that your technology, this Commotion, is a way of getting us to the point where we can do similar things with phone calls, with all of our communications?
Yes, so today we take for granted, and it's understood as normal, that if I go to my office, if most people that are listening go to an office, you have certain shared resources. Almost every business in the country, on the planet, will buy bandwidth in bulk and shared amongst the computers in that office. It's normative to have a printer that is shared by a number of users. It's normal to have servers, like an email server. It's a shared resource that multiple people can access. We don't call these things communistic or socialistic. We don't look at office networks and say, oh my God, you're putting the telcos out of business. We think of that as smart business practice. What Commotion does is elevate that exact same model to be a resource for neighborhoods and communities and metropolitan areas writ large. What we're saying is those exact same economies of scale and cost savings and benefits, right? When I call to my colleague down the hall in my office, I don't pay for that phone call. It's all on the internal network. I want that same resource to be available for communities.
So I have, living down my block on the other side of the street, a friend who's technically inclined as well. What do we do to set up a local Commotion network?
So if you have Wi-Fi devices, hardware, and you can see from one end of your block to the other, you just set them up, you flash that device, either with the software, say if it's a router, or you download the application onto your cell phone or onto your computer, and you install it just like you would any other firmware or application. And the network itself is built to self-configure. So once you have multiple devices that have the software on it, they identify one another and set up that network automatically.
So you're not selling like stations that we go out and attach to street poles and that sort of thing?
No, we are hardware agnostic, and we don't sell anything. We give the software away for free. It's all open source. It will always, forever, be freely available. And it's built to run on a variety of different platforms so that you can reuse whatever hardware happens to be available in that locality. This is critically important in that we don't want people to have to use specialized hardware. We don't want to have to ship specialized hardware into some of the world's hotspots.
But that makes a lot of sense. You're building a solution for the world, not a solution for neighborhoods that can just happen to afford hundreds of dollars of new gear.
And we're building a solution that's meant through and through to be low to no cost. So if you can recycle antiquated equipment, if you can take your old computers that are end of life and turn them into Wi-Fi routers running Commotion, if you can take the cell phone that you're no longer using and turn that into your wireless hotspot that's interconnecting your house to your neighbor's house, that's a fantastic opportunity.
So one of the things I've been curious about, something that Jared Hardy is working on in Los Angeles, would be the idea that if we interconnected 5 different houses and we have 5 different interconnections, each of us has our own interconnection, and then we have this local network that we've built. Does the Commotion software deal with that sort of situation where you have multiple different paths in and out?
Yeah, and not only does it deal with that functionality called multi-gateway support has been native into these systems for the last half-decade at least. What we're working on today is multi-homed systems where you break up data and you ship it via multiple different routes to an endpoint. So you can imagine you take, one communication, you break it up into 5 different streams, and you put it out through each one of those different gateways. Now, not only do you have security in terms of end-to-end encryption, but even were you to somehow compromise that on one of those pathways, you still get gibberish, because until you get all 5 of those streams, you don't actually have the message.
Okay, so that's still being worked on?
Yes, that is a much more complicated problem.
I would imagine so. Is there anything else that we haven't touched on that we should know about Commotion?
Commotion right now is in beta. We have a developer release that's out there. We know that there are bugs that we haven't found yet. We really would love to see a lot of people banging on these technologies and telling us what works and what doesn't work. Commotion is also deployed in real-world scenarios and places and locations. And so we know that the basic functionality of the system is fully operational. We are moving towards a version 1.0 at the beginning of next year. And that's when I would say we'll be ready for the non-techies to really spread this communication system far and wide. The most likely risk vector for the project isn't technological, it's political. These are highly disruptive technologies that a number of incredibly powerful constituencies and lobbying groups would love to kill and prevent from ever being available to you and I.
Right, it's not just Time Warner Cable or AT&T that's horrified at this idea. It's any local government or state government or federal government that does not want its citizens to be able to talk secretly.
Yeah, in essence, you have an unholy alliance between law enforcement officials that see safe communications as dangerous, a copyright industry that sees us as the enemy, and ISPs that view us as simply a commodity to be mined for more and more money. And those three constituencies, the bad parts of those three constituencies, would love to see this technology mothballed and never made available to you and me.
Actually brings up a question that I thought of earlier and I forgot to ask, which was, if you're a municipality that is building or has built a network already, what reason might I have for encouraging people to use this fiber that I've pushed into every neighborhood and make it available to set up Commotion clouds and that sort of thing?
Fiber has capacity and cost efficiencies that are second to none. Whenever anyone has the opportunity to lay fiber, they should be doing so. On the other hand, having ubiquitous coverage has vexed even the most cash flush endeavors. And when you have an organic system of wireless connectivity where you can reach via multiple hops inside buildings and across parkways, and where you can automatically reroute traffic based upon optimal pathways when you have congestion in one part of the network, it becomes very clear that there's this incredible synergy between fiber backhaul and wireless systems. And so the smart people are looking at how do you integrate the fiber plant that's within their communities with the agility of next generation wireless. And when I look at where 802.11n systems are today, where 802.11ac systems, gigabit wireless.
Right, these are different Wi-Fi standards.
Exactly. These are standards where 5 years ago I was in arguments saying, no, we're going to have gigabit wireless. And I was told it is physically impossible. In the same way that I was told it is not possible to have scalable mesh networks. Well, both of those end up being entirely false. We have gigabit wireless. It's coming. And it's also the case that it pales in capacity compared to the fiber plant. But what you want is both. You want the cost efficiencies, you want the capacity that fiber brings you, and the agility and mobility of wireless. And if you build your wireless right, you end up with a system that can do things that today seem like science fiction.
Excellent. Thank you for joining us for Community Broadband Bits.
My pleasure.
We look forward to, I'm sure we'll be talking to you in the future as this progresses.
That was Christopher and Sascha Meinrath from the Open Technology Institute. For specific information on Commotion and the info you need to get involved and get started, visit the project website at commotionwireless.net. We want your questions and your comments. Email us at podcast@muninetworks.org. Follow us on Twitter to learn about all the most recent developments relating to community networks, telecommunications, and broadband policy. Our handle is @CommunityNets. This show was released on April 9th, 2013. Thank you again to D. Charles Spear and the Helix for their song, Freddie's Lapels, licensed using Creative Commons. Thanks for listening.